Yeah. So hi, everybody. My name is Russell Wolf. I'm a Kotlin multi-platform developer at TouchLab. I'm also a Google developer expert for Kotlin. Here. I don't know if we can bring the mic up a little bit, or I'll try to talk a little bit louder. Is that better? Or can people still not hear? Is that working? Okay. Oh, there we go. Okay. You just needed a button to get clicked. Cool. My name is Russell Wolf. I'm a Google developer expert for Kotlin. I do Kotlin multi-platform development at TouchLab. Been doing this stuff for a couple years now, and gonna talk a bit about some of what I've learned. So I don't know if this is clever or silly, but I'm organizing this talk by just breaking the title up into sections. So we'll start with Kotlin multi-platform. What is it? Kotlin, many Android developers know kind of largely as a language that they use for Android development, but you can also use Kotlin on other platforms. You can use it on native platforms via LLVM, which lets you build things like iOS apps. You can use it in JavaScript in the browser or in Node. There's now a WebAssembly backend that's being worked on. So you can take the language that you love and run it in all of these different environments. And it's structured in a nice way where you can have both shared code and platform-specific code so that you can share the code that you want to share, but still run it in a native environment and still kind of access the native parts of that native environment when you want to. So this tends to mean that your shared code is just one more library along with all of your other dependencies. But it doesn't have to be. Like, you could build everything in a single code base and use Compose for your UI, but that's not kind of the typical way people think they're doing things today. We'll see how that changes in the future, of course. Kotlin multi-platform has been was experimental for a couple of years, has been stabilizing over the last few years. It's currently in beta and will be stable soon. So this is the U-Track ticket if you want to kind of pay attention to when that's going to happen. Even though it's still in beta, it's very usable in production. So we at TouchLab have been using it in production for several years now. So has a bunch of other companies. You can see JetBrains has a bunch of case studies on their website of people who've been using it. And we're seeing some interesting kind of changes happen as things stabilize. So the list of targets is being narrowed a little bit, where there were some embedded targets that weren't being used as much that are being removed. Some older 32-bit things are being removed so that the platform can kind of focus on the things that are going to be supported longer in the future. And we're seeing a similar thing happen also on the API side, where over the last couple of Kotlin versions, JetBrains has been marking certain things as essentially more or less stable so that you know what are the parts of the overall Kotlin multi-platform environment that you can depend on as being perfectly stable once we hit this stable milestone. And that does mean that there are going to be some things that aren't going to stabilize immediately, but at least you'll know what those are, and you can plan your code and your architecture around that. But that's kind of a little in the weeds details. If you're just kind of starting this stuff for the first time, a mental model I like to think about for how to approach Kotlin multi-platform is this Venn diagram, where the left side is the Android code that you might be used to as a native Android developer. And you can peel certain parts of that out that don't depend on Android and don't depend on the JVM to build this common code, which can then be shared to your iOS side. And that can then get combined with iOS platform-specific things like the foundation library and other things that are in the typical iOS SDK. And then the Kotlin multi-platform toolchain kind of binds all of that together, builds the right sources to the right targets as you need them. You've got this nice shared code environment. And I should say also, like, there's more to this obviously than just mobile. but the Venn diagram gets really complicated, so this works better for a slide. So that is Kotlin Multiplatform. So what does it look like doing a Hello World app in this environment? And just a moment. One of the easiest ways to kind of spin up a Hello World project is there's a KMM plugin that's available in Android Studio that gives you these new project templates for Kotlin Multiplatform apps. There was a time for a while where, I mean, like 4 or 5 years ago, there was kind of no good templates like this. For a little while, IntelliJ had a good one, but these days, kind of the best way to spin up a Hello World, I think, is probably this one, or one of the quickest ways, at least. And what it gives you is, it gives you kind of a small amount of Hello World code, which we'll talk through a little bit. This is the entirety of the common code. So you have a platform interface. You have this expect function get platform. So expect is a keyword that multi-platform adds to the language that lets you expect something in your common code, and then there's a actual declaration in your platform code that has the implementation. And then this greeting class makes use of those. It's kind of like your application logic. So it's a pretty simple amount of code. This actually has some patterns though, that I really like to it. So a lot of people, when they first start out writing KMP, they see this new expect keyword and they want everything to be expect. So they'd write like a expect class platform, and then you have like an actual platform in Android and iOS. And this is nice and works for small things, but it has some disadvantages because expect actual forces you to have a single implementation per platform. So you don't have the ability to substitute something else out for your tests or to just have other options. Using interface like you might have in your single platform code gives you that more flexibility. And then the expect function gives you a default, sort of like a dependency injection. So that was the common code. On the Android side, we get a implementation of that platform that calls into the main APIs to get the current platform version and gives the actual declaration to get the default platform. Similarly, on the iOS side, the implementation is different because now we're talking to iOS APIs instead of to Android ones. And a quick little aside that I'll pull out here. So this is not in that Hello World template, but a natural thing to kind of try next is to implement that iOS platform in Swift instead of in Kotlin. This is something that you're able to do. You're not able to expect actual at that point, but so you have to kind of manually inject that in a different way. But it gives you some nice flexibility when you're doing larger things. Running things in Swift is closer to what your existing code might already be doing. So if you have existing iOS implementations of things, you might want to kind of do your iOS implementations in this way. It lets iOS devs write the implementation in the language that they're used to, just at the cost of it not all being in the same module. So on top of the shared module, it binds things to an Android UI, which that's a bunch of code, but the important parts are a greeting view composable that binds some text. The text that it binds is that greeting class from our common code. And then iOS has the same thing, a bit of Swift UI ceremony, but the important parts are calling that shared code and rendering it into text. And this template is a nice playground for getting your kind of early intuitions for how KMP works. So there's kind of 5 major locations here. The shared module at the bottom has common Android and iOS code. And then there's Android and iOS API app layers above it. And so you have code stubbed out in each of these places to do some experimenting and try things out. something you might find is the line between the Android app and the Android shared can be a little blurry. On the iOS side, it's real stark because the app is Swift and the shared code is Kotlin. If you're playing with these templates, there's also some other knobs you can turn, some other configurations you can do. It gives you options for how to export your Kotlin code how to export your shared code to Xcode to consumer from iOS. So you can bind a framework directly. You can use CocoaPods or SPM, which are iOS package managers. The CocoaPods developer experience is a little bit more tuned on the Kotlin side, but SPM is what iOS developers are using more. So you can maybe talk to your iOS developers and see what they prefer. It can be a nice conversation to sort things out. Excuse me. As you start to move beyond just a hello world, TouchLab has this CampKit sample that showcases some of our preferred architecture patterns and libraries and things. So it can be a nice place to look at next as you're doing more complicated things, get some ideas. Some parts of it are due for an update soon, so stay tuned for some of that. But it's still a nice place to see. We do shared view model wired into Compose into UI. There's a shared repo layer with networking database, and it shows off some of our preferred dependencies and things like that. And there's some common themes that you might see across Hello World, across CampKit, across other early project samples. They often have a higher percentage of shared code, which might not help you if you are in an environment where you don't want to share everything. They tend to be monorepos, but that doesn't always help you if you have existing apps in separate repos. They tend to kind of wire the Kotlin build directly into the iOS build, which means you need to have all of the Android and JVM tooling installed to run the Xcode build. And they tend to be single module. They tend to be kind of less complicated than you might get in a real production environment. So you get a little bit of this draw the rest of the owl problem, where you start with the hello world, but you don't get all of the tools to go further. And I feel really bad. Someone at the speaker dinner gave me the idea for this slide, and I forget who it is. So come find me and yell at me. Sorry. But yeah, let's talk a bit more about the real world. And this isn't going to answer every question that you might have, but hopefully it gives you some ideas for how to think about things as things get more complicated. And the first point that I'll make is, of course, sharing is caring. Obviously, having shared code is a huge benefit. You can avoid duplicated work, take less dev time, you can avoid implementations that diverge and fix bugs just once. So often that's a nice goal. But sometimes not sharing is caring. And especially when you have existing code bases and existing teams, your iOS devs might be a lot happier writing things in Swift than in Kotlin. And they're really good at it too, and you might want to leverage that. So your shared code doesn't have to be all of your code, and that is okay. The strength of Kotlin is that you have the ability to dip into platform-specific stuff when you need to, and you should leverage that and find your team's sweet spot for where you want shared to be. So maybe that's everything. Maybe that's your view models. Maybe that's just a tiny bit of business logic that's really important. And sometimes you just want to start small and grow. And sometimes actually you might go the other direction. So we've talked to a team recently who started with shared view models and found it wasn't flexible enough for them and moved to shared just a repo layer. So again, it's what works for each team. So here is a realistic picture of a software engineer. And the important things here is There's a person and there's a computer, and both of those are important. There's not just the tech, there's the human side. So every team and every person has different skills and preferences, and figuring out how you're going to do shared code is as much a social problem as a technical one. So the driver KMP usually comes from the Android side, but you need to keep the wants and needs of the iOS side in mind, or you're never going to be successful. You can't sell KMP to your iOS developers by telling them they have nothing else to do. They don't work. So let them do what they do best. Find the parts of the code that they want to write and share the pieces that they don't want to write. There's also a lot of different ways that your team structure might impact the ways that you want to structure your shared code. So in a Hello World app, you just have one developer usually. When you have a bigger team, you have to be more helpful about things. And there's lots of variables here. So you might have a small team versus a large team, a smaller team. Usually people are touching all parts of the code base more. A bigger team, you might want to kind of split things out into libraries and publish them as versions and separate things. A smaller team, you might be sharing more. Like an established team, you might be starting small and sharing less and growing over time. A smaller team, you have kind of fewer worries about who owns what. You're more likely to have kind of a thinner UI. But all of these variables kind of vary a lot by different teams. And so you just want to, you want to remember that what you might see one group doing isn't necessarily what you want to do. And you want to kind of figure out figure out with your entire team what you do all want to do. And one piece of all of this that I mentioned briefly is kind of the difference between monorepo and multiple repos. What you often find yourself wanting in larger teams is being able to take your shared code and not just build it from source every time, but publish it as a library. So it's usually less important for smaller teams, but it's almost mandatory when a team gets big enough. The benefit of it is iOS gets to avoid the Kotlin and JVM tooling. It also means you don't need to build Kotlin native as frequently. The downside is you have slower iteration because you need to publish and build each time. And TouchLab has a tool called KMMBridge that's intended to help with this SDK publish side of things. So we released it last fall. And it's a Gradle plugin that helps configure the publishing side of shared Kotlin SDKs. So it makes your Kotlin shared code look like a traditional iOS dependency that can be published to Swift Package Manager or CocoaPods. And we have a kind of default setup that can be nice for a small team starting out, but it's also very pluggable so that if you have physical infrastructure, you can use the CI system you have and things like that. And a lot of this is still a little bit work in progress. So it'll work for you, but we're interested in feedback for what people need and how we can improve it. So let us know. And again, if you're thinking about things like CocoaPods versus SPM and you're not sure what that means, talk to your iOS team. It's a good time to ask for help and get everybody involved. Another piece that comes up more and more as things scale bigger is modularization. So a Hello World app tends to be one module, a real world app gets bigger. And there's a lot of subtle limitations to this around KMP. So when Kotlin native builds a library module, it has this closed world model that essentially means when you build a framework, which is the iOS dependency format, if you have more than one of them, they're essentially completely separate worlds, and shared dependencies are duplicated and can't really talk to each other. So if you have a setup like this, where you have multiple modules, if they need to be independent, or else they won't be able to talk to each other very well. Or they won't be able to talk to each other anyway, so you need to make them independent. And that can be limiting, so what you often want to end up doing is something like this, where you have a iOS module at the Kotlin layer in between that binds things together, so that your things underneath it can talk to each other in the ways that you need them to. There can be some namespacing complexities to this, because you're going to have a lot of modules that are essentially sharing a namespace. And that's kind of getting improved over time by the Kotlin team. Yeah, you can kind of, depending on what the use cases are of your different modules, you might or might not want to combine them under a single umbrella in this way. Another production concern that comes up a lot that you don't think about in a Hello World app is how big is it? A Hello World app is always tiny. You don't run into the issues of app size. But the real world has major consequences when things are too large. And a subtle thing that happens in the Kotlin build process is that when you have public declarations, it tends to add a lot to your binary. So the private things in Kotlin are relatively small when they're bridged over, but because it's just kind of a little bit binary. But when you have this Objective-C interface that's generated for public things, that can add a lot of size. And so the kind of takeaway lesson for that is limit how much of your interface is public to only the things you need, and then that can shrink kind of all that extra generated code as well. Something that can help with this a lot is so the thing that makes it difficult sometimes is Kotlin's default visibility is public, and so it's easy to accidentally expose a lot of things and then balloon your size. If you use the explicit API mode in the compiler, it will force you to write public every time, and then you're thinking about it and you're more about it. You also want to watch out for generated code. So if you're using something like SQLite, its database models are all generated as public classes, and so if you have a lot of things in your database, you might want to move that down a layer so that it's not exposed in your public API. So things like splitting your interface and implementation into different modules also help with this. So Hello World has generally a small API surface, but as things get bigger, it gets more complicated to figure out what your API service looks like and how it all fits together. So this is like every different construction toy and adapters between them, because that's a lot of what you're doing when you're writing an interface to kind of bridge between Kotlin and Swift. You have to do a lot of thinking about what that API design looks like so that your Kotlin side can write idiomatic Kotlin and your Swift side can consume it idiomatically in Swift. Often what that ends up meaning is you have a bit of a translation layer at that boundary so that you can kind of fit these things together in the same way. And a little bit of advice I usually like to give around this is don't be afraid to do a little bit of extra work to make this interop work. So it can sometimes feel like you're doing excessive wrapping and bridging, but sometimes that's what it takes to kind of make everything glue together nicely. But also, TouchLab has some tooling that can help with some of the common use cases of this. So we just released publicly this plugin called Sky that it's called the Swift Kotlin Interface Extender. And it's designed essentially to make the Swift code that is seen that's generated from your Kotlin feel a lot more idiomatic to a Swift developer. So it gives you things like exhaustive switching over enums that you don't get naturally from Kotlin's default interop. And it gives you, it takes your flows in Kotlin and turns them into Swift's async APIs. So it's newly open source. We'd love for you to check it out and tell us how it works for you. we can really help to solve some of these problems of API boundary layer complications. So come talk to us if that's something that's interesting to you that we help you to adopt. So the last bullet point that I had in that first thing was just some dots. But we're going to talk a little bit about kind of some real-world examples in code thinking about some of these things. And the first one I'll do is talking through ways to handle flows coming from your Kotlin code. We often like to build reactive interfaces. This is the natural way to do that in Kotlin. And we want to avoid changing the Kotlin patterns that the Kotlin devs are used to just to make the internet better, but we also want to make things feel natural to the iOS side. So if you just do the thing that you wouldn't actually do in Kotlin, you get, this is what it looks like coming from Swift. So you got this like weird, ugly flow type, and it's hard to actually use it. It is actually possible to consume this, to write. You have to basically write a collector class that implements kind of the Kotlin flow collector interface. It's this big pile of code that you don't actually want to write. But even if you do that, there's still some disadvantages here because flow is an interface, and the generic arguments and interfaces don't make it through from Kotlin to Swift, and so you've also lost type safety. And so there's like all these things that are not very dynamic about it. You can make this a little bit better by adding this adapter layer on the Kotlin side. So flow adapter class like this, and this is how I would have done things kind of a year ago. You can write a class that kind of wraps around the flow, holds onto the generic argument, gives you a way to subscribe to it, and pass callbacks that you can wire into Swift. So this lets you kind of forward emissions and errors and cancellation. And then you write some extra bridging code on the Swift side too, to then convert that to async stream, which is Swift's kind of observable async API. And then you write some more wrappers so that your repository exposes a flow adapter on iOS instead of a flow. And then finally, you can somewhat idiomatically in Swift await on things. So you can do this for await pattern. That's how kind of Swift interacts through its async streams. But like those adapters are a pain to maintain. There's some libraries that can help with this. So KMP native coroutines is a plugin that kind of generates a lot of this code for you. But it still has some complexity to it. You still have to, you still need a home for some of these iOS specific things that can be kind of awkward. So what Sky does really nicely is kind of generate all this stuff under the hood for free, and kind of swap out the things that it needs to, so that from Swift you kind of just see the Swifty parts that you want when you've written the Kotlin-y things on the Kotlin side. So the flow gets transparently converted to an async sequence, the cancellation gets forwarded, and without needing to do any extra gluing, you get kind of the idiomatic patterns on both sides. So that's just a cool demo of how Sky works. I'll also talk through a couple just case studies of different code migrations that we've done over the last couple of years that kind of show some other things where you have to do a little bit more manual adapting and wrapping. So there's a client that I worked with maybe 2-ish years ago that had a big complicated synchronization logic that was running through a socket. And it was using, they had this socket connection class that had this complicated Java socket pile of code. It wasn't very well abstracted. And we didn't want to rewrite all of the logic inside of it and risk breaking something in the existing app, but we wanted to move it to iOS. And then there was this sync service that made use of all of that. And that we were able to move into common code, but we needed to have a shared socket connection underneath it. And essentially what we did is pull out this socket interface that just had these app operations that we needed to run from inside of that connection class, and then a factory to create new ones. And then the interface we had separate implementations for on Android and iOS. And the specific details aren't super important here, but the general idea is this sort of refactor is the same kind of thing that you might have done to like make your code more testable or kind of do other bits of re-architecting. Finding kind of the right seam between your shared code and your platform code is kind of a skill that you pick up over time as you do more of this stuff. But the sorts of skills that you might have from other sorts of like clean code and clean architecture thinking and refactoring thinking also help you with this sort of refactor. Another example I'll hit on is a client that they had essentially a SDK for white labeling various apps to do different things, and it had an analytics and engine inside of it that might have a bunch of different implementations depending on what the specific client of theirs was using. So there was like a handwritten one, there was a Facebook and a Firebase one, and all of the analytics SDKs that they were talking to, or the Facebook and Firebase SDKs they were talking to were platform specific, and so we essentially so we were able to kind of define this interface, give it a bunch of implementations, swap them out as we needed to, and sorry, I'm forgetting what I was about to make. And even pull out part of the issue with the Facebook and the Firebase ones was those have to pull in external dependencies. And so we were able to pull that out into separate modules, so that dependency was only forced if you actually included that module. But so we had kind of, some of these live in common. The Facebook and Firebase ones, there's a separate Android one that talks to the Android Firebase APIs, and iOS one that is defined in Swift and talks to the Swift APIs. And one of the things that's nice about this is you get to, like a question that people often ask when they're starting out in KMP is like, is there a library to do X, Y, Z, whatever thing I'm trying to do? And a lot of times there won't be a shared one yet, but there almost always is a native one. And so you can find ways to kind of bind that native SDK into the thing that you're trying to do, build your shared interface around it to talk to from your common code, and you get that shared library for your use case, even if a general one doesn't exist. So that was a whole bunch of examples in code, and I'm sorry I droned a little bit. But the overall lessons are that the real world can be complicated. Hopefully I've given you kind of some insight into some of the complications that can come up, some of the ways you might want to think about them. But kind of remember some of the main lessons. So the human element of things is really important here. And that's like an easy thing to forget when people are first starting out. And sharing everything doesn't need to be the goal, and you can find what is the right level of shared code for your team. So if you're interested in kind of more on all of these things, if you go to the TouchLab website, we have this new service we're starting out called TouchLab Pro that has a couple different tiers that can, some of it is kind of documentation talking about our opinions on these sorts of things and more. There's kind of more expensive tiers that give kind of a support portal where you can ask us questions. So if you're an individual or a team who's adopting this stuff and wants more support, this can be an option. We're also just interested in hearing more in general about what you need. So if you are starting to adopt Kotlin Multiplatform and something isn't working for you, you want some library to exist, you need some help implementing a certain thing, come talk to us. We have a booth upstairs. This QR code is a form you can fill out to just let us know who you are and what you're looking for. So yeah, let's chat. And thanks. So there's that QR code again if you want it. I'm also happy to answer questions and things. I'll be at the TouchLab booth some. If you're looking for me and I'm not there, someone there can find me. So yeah, I like to talk about this stuff. TouchLab likes to talk about this stuff. Let us help you on your KMP journey. And thank you.